Welcome back. Time to gain access to our Windows 10 machine using the SMB Ghost vulnerability. For now we managed to scan it to see if it's vulnerable, and we also managed to find a tool that we can use to crash the target system. But ideally, we don't want to crash it. Instead, we want to gain shell on that target machine. Well, with this vulnerability, it is not that easy. There are some things that we need to know in order to be able to remotely exploit it. Let's see what I mean. The first thing that we must do is we must download the tool that we are going to use for the exploitation. And I already checked a few of them out, and I found the best working one to be this ZecOps CVE vulnerability. If you just type the same thing that we typed from the previous video, which is the vulnerability name and then GitHub, you should find this ZecOps link to be on the first page. Click on it, and down here we can see the files that we get, and right here we also see the usage of the tool itself. But before we get into all of this, let us first download the tool from GitHub. So let's copy the link right here, copy, go to our terminal and type git clone and then the tool link. Press enter, and here it is, it finished downloading. Let us type ls and we will see a bunch of these directories with the same name. This one, however, has this extension of RCE and then POC, which stands for Remote Code Execution Proof of Concept. Let's change the directory to that directory. And if I type ls right here, we're going to see a bunch of files. So we get this .bat file, which runs on Windows. We get this SMB Ghost assembly shellcode for the 64-bit version. And we get this Python SMB bleeding ghost file, which is the exploit itself. But we don't really know how exactly do we combine all of these files. So let's go back to the page and check out the usage of the program. The first step right here tells us that make sure Python and ncat are installed. Then run this .bat file on the target computer and adjust the offsets at the top of the SMB bleeding ghost.py file according to the script output. What does this mean? Well, let's go to the Python file first, let us nano it, to see what offsets do they mean. And I assume they mean these offsets right here. As we can see, there are 5 of them, and they have different offsets. But you might be asking, well, it tells us right here that we must run this on the target computer. And what's the point then of calling this an exploit if there is a file that we must run on the target computer first? Well, let's go to the note down here. As it says, you might be wondering why it is necessary to run the .bat file script on the target computer. And doesn't it defeat the whole point of the remote code execution being remote? Well, here is the explanation. These offsets are not random and are the same on all Windows instances of the same Windows version. One could make the attack more universal by detecting the target Windows version and adjusting the offsets automatically, or by not relying on them altogether. What does this mean? Well, these offsets right here are the same for the same Windows version. So for example, this Windows version that we got right here, if we had 1,000 machines that were running the same Windows version, well, it is enough that we run this .bat file on this one to check out the offsets, then we adjust the offsets right here inside of our exploit, and then we can attack all the 1,000 machines without having to run the .bat file on them. But a different version of this Windows machine might have a different offset, which will then make our exploit not work. So we must check the offsets first. How we're going to do that? Well, as it says right here, we're going to run the .bat file on the target system. So I already downloaded the tool right here on my Windows machine. Here it is on the desktop. And what you can do is you can just open the Windows 10 machine, open the Internet Explorer, type the vulnerability name and then GitHub, navigate to the ZecOps tool, and then if you click on it, click on this code arrow right here, and click on download zip. This will download the tool for you, and you should have it right here on the desktop right after it. Great. Once you do that, what we can do is we can navigate using our terminal to that tool, so cd desktop and then cd CVE. If I type dir right here, and I run the bat file, of course you can run it using command prompt, or you can just double click on this file and double click on the calculate target offsets. As we can see, this will open another terminal, and this will give us those 5 offsets for this particular Windows 10 version. What we must do right now is we must change these offsets to match inside of our Python file right here. So let's check it out. Here we got 2D170. The first one is the same. 32210. The second one is also the same. The third one also appears to be the same. The fourth one is different. Here it ends with 370 and here it ends with 410. So let's change that first. Let's type it 370. And the last one is also different. So here it is BAFA8. And here, if we change it, BAFA8, now everything is good. So if we Control O to save this exploit, now we should have a working exploit. We can close this. We don't need it anymore. We can also close this. And if I go back to the page to check out the next step, it tells us run ncat with the following command line arguments. So the purpose of running ncat is because once we exploit the target and we run the payload, it must connect to somewhere. Now, this listening for the incoming connection, Metasploit framework did for us automatically. Right now, we must do it ourselves, and we're going to do it with the help of ncat. So to listen for the incoming connection, we can type nc and then -lvp and then the port number. In this case, let us listen on port 4444. This will listen for the incoming connections, and once we run the exploit, the target machine will try to connect back to this port number right here on our IP address. Therefore, right after it, we should have a shell pop-up right here, and we should be able to execute commands on target machine. Great. Let's check out the next step. The next step is to run the .py file while following the command line arguments. So the command that we must run is the file name, then the target IP address, then the Kali Linux IP address, and then the port that we're listening on. And this reverse shell IP is just the IP address of the machine that you're listening for the incoming connections. And you get the explanation right here as well. So let's try it out. We're listening right here already, and let us run the file right here. We're going to use Python 3, smb bleedingghost.py, then comes the target's IP address, which is, in my case, 192.168.1.5, as it says right here. Then comes the IP address on my Kali Linux machine, and I'm going to check it out inside of a third terminal real quick. It is .1.12. So let's type it right here, and the last step is to specify the port number that we're listening on, and in our case, that is the port 4444. If I press enter, we get an error that says no attribute WinDLL. And I knew this error will come up. The solution to this is to run the exploit from a Windows machine. So this file right here must be ran from another Windows machine, and then we can redirect the connection to this Kali Linux machine to pop a shell. Why is that? Well, this C-types library has no attribute WinDLL, which is only to be ran in a Windows environment, I believe. So let's test it out. For this, I'm going to use my main Windows 10 machine right here to run the exploit, and I will redirect the connection, once exploited, to the Kali Linux machine that is already listening for the incoming connections. Now I know it sounds a little bit complicated, but let's give it a try. I already downloaded the exploit right here. Here is the file containing all of the other files. And if I open my command prompt, then I navigate to this directory right here containing the exploit. What I'm going to do is I'm going to run the exact same command that I ran previously on my Kali Linux machine, just this time I will be running it from my main Windows 10 machine. So the IP address of the target is first, then comes the IP address of the machine that is listening for the incoming connections. And this might sound confusing, but this is still the IP address of our Cal Linux machine. If you want, however, you can also connect back to this Windows 10 machine, but in that case you must install netcat for Windows and listen using netcat from a Windows machine. And then right here you would specify the IP address of the Windows 10 machine that is running the exploit. Since there is no need for me to do that, I will just specify the Cal Linux IP address, and the port number is 4444. Great, the command is here, and if we execute it, it will start the exploit, and sometimes this exploit will crash the target, as we can see right here. The first try of running this exploit crashed our target machine. And this is something that you must get used to once running these type of exploits. So what I'm going to do is I'm going to Control-C this to quit this exploit. And then what I'm going to do, clear the screen using CLS command, and I will run this command once again. Just I will wait for this Windows 10 machine to boot up once again. And we're going to give it a second try. And now that we're logged in, I will run the command once again. Now there is a chance that it will crash once again, but hopefully it will not. And here it is, it crashed once again, so I'm just going to restart it again real quick and then run the exploit for the third time. Hopefully the third time it will work. Okay, here it is, and hopefully the third time will be our lucky run. Let's run the exploit. For now everything seems to be working. We haven't reached this point in the past 2 tries, so hopefully right now the target will not crash. And what we're looking for at the end of this is, after the exploit is done, we're looking to gain a shell right here inside of our Cal Linux machine. So let's wait for this to finish. It tells us right here, wrote shellcode. And if I go to my Cal Linux machine, here it is. We got the shell on our Windows 10 target machine. If I type who am I, we are the system level account, so we're the highest level account possible. If I type ipconfig, just to check whether we have the same IP address, and that indeed is the same machine. So we successfully exploited the Windows 10 target machine. Just for this we had to use a Windows machine to run the exploit, because of some libraries inside of the Python file. And if you notice right here, it tells us that if we disconnect and if we exit this exploit, the target will probably crash. So what we would want to do is we would want to execute all of the commands that we want to execute, do what we need to do on the target machine, and then after we've done and we've exited the shell, we can go right here, stop the exploit, and once this exploit has been disrupted, that will again crash the target machine, as we can see right here. Just this time we managed to run the shell, we managed to execute commands on the target machine for as long as we wanted before crashing the machine. So the goal right here is to first gain the shell, and then the machine will crash, and not crash the machine at the beginning of the exploit. But that is something that we do not have control of. So sometimes you will gain the shell, and sometimes you might crash the target machine. Okay, great. So we successfully exploited Windows 10 machine. We did it manually, with the help of tools that we found online. We also set up our own listener that was waiting for the incoming connections. And right now that we covered all of these vulnerabilities, starting from the next video, we're going to see how we can attack targets that do not have any vulnerability. So we're going to see how we can generate our own payloads and how we can deliver them to the target machine. See you in the next video.